This is an analysis from Alpha Business Media. Welcome back to the deep dive. We've got a really specific and high-stakes topic today. We usually focus on market moves, maybe some new legislation, but today we're looking at the physical collision of two massive forces, artificial intelligence and energy. And the interesting thing is, our analysis isn't taking us to Silicon Valley or Northern Virginia. We're going to the Himalayas.
It is a bit of a curveball, isn't it?
Oh.
I mean, when we talk about AI infrastructure, the conversation is almost always about the chips.
Always.
The architecture, the training data, but the ground is shifting. The real bottleneck for the next decade isn't just silicon, it's the kilowatt hour.
Physics is catching up.
It really is.
I was looking at the source material, and the numbers on energy consumption are just staggering. The NVIDIA H100 GPU, it's the engine of this whole boom.
Right.
But a single one of those chips under full load pulls about 700 watts.
Which, in isolation, that doesn't sound like a catastrophe.
No, but then you put it in context. That's enough electricity to power an entire Nepali household for a day.
One chip, one home.
And nobody is installing just one.
That's the whole point. We're not building servers with one or two anymore. We're building clusters, 10, 20, sometimes 50,000 of these things.
So we're not building a computer room, you're building a power plant.
You're building something with the power appetite of a small city, yeah.
Analysts are calling it the AI energy crisis. And for good reason. The demand is just outpacing our grid capacity.
And that leads us to the core tension here. You've got this global power famine for AI, especially clean power. And then you have Nepal sitting in what the report calls this paradox of surplus.
It's the definition of economic irony. You look at their neighbors, India, Bangladesh, they're struggling. Grid instability, brownouts, tons of coal.
Right.
Meanwhile, Nepal has all this run-of-river hydropower. So when the monsoons hit, the rivers swell. The turbines go full tilt, and they literally have to spill gigawatt hours of clean energy.
Just let it flow down the river.
Exactly. It's a national asset worth millions just washing away because there's no one there to use it. So our mission for this deep dive is to connect those two dots, a global need and a massive local surplus. The big question is, can Nepal pivot from just exporting raw electricity to exporting processed data?
Can it become the green battery for AI in Asia?
That's the idea.
And on paper, the logic is, it's really seductive,
Yeah.
a perfect match. But, as we're about to see, it's not as simple as plugging a server into a dam. There's a lot of economics, geography, and some pretty big institutional hurdles.
Let's start with the money. That's where these decisions usually land. The report calls electricity the new oil. Walk us through that. Why is the kilowatt hour suddenly the key metric?
It all comes down to CapEx versus OpEx.
Capital versus operational expenditure.
Right. The CapEx is the chips. An H100 cost, what, $30,000, $40,000? And that price is basically the same whether you ship it to San Francisco or Kathmandu. It's a fixed cost.
But the OpEx, the cost to actually run it.
That is intensely variable. That's your power bill and your cooling bill. And over the life of a data center, those OpEx costs can actually be more than the hardware itself.
And that brings in locational arbitrage.
Exactly. It's a classic strategy. You move your manufacturing to wherever your most expensive input is cheapest. We usually talk about it with labor.
Moving a factory for cheaper wages. But here, the labor is the electron.
Precisely. And if you look at the big hubs now, the price of that input is spiking. Take Data Center Alley in Northern Virginia.
Huge chunk of the world's internet traffic goes through there.
It does. But the grid is so overloaded that utilities are telling new customers they might have to wait until 2026, maybe 2027 for a hookup.
That's a lifetime in the tech world.
It is.
Yeah.
Or Singapore. They put a full moratorium on new data centers. They just ran out of power and land.
So what about a place like India? Lots of companies are looking there.
They are. But the report flags a big pricing problem. Businesses there are paying, what, 10 to 12 US cents per kilowatt hour?
Which is already high.
It is. And that's just the sticker price. It doesn't include the reliability tax. The grid isn't perfectly stable, so you have to build these huge, costly diesel generator backups.
So you're paying more for dirty power that hurts your ESG scores.
Exactly. Which big tech really cares about right now.
So enter Nepal. What kind of price could the Nepal Electricity Authority, the NEA, actually offer?
This is the opportunity. The NEA could likely offer power purchase agreements, or PPAs, at around 4 to 5 cents per kilowatt hour.
We're talking half the cost of India, roughly.
At least. And this is where the math gets really powerful. If you cut your power bill by 50%, over the 10-year total cost of ownership, the TCO of that data center.
Yeah.
That translates to a 20 to 25% reduction in your total costs.
It's massive. For a hyperscaler like Google or Microsoft, a 25% TCO reduction isn't just savings.
It changes the entire business model. This isn't about CSR. It's not about being green for PR. This is a hard-nosed bottom-line financial decision.
Okay, so the economics are a slam dunk. If I can cut my costs by a quarter, I should be booking my flight.
You'd think
So
like
there has to be a catch, and I'm guessing it has to do with the speed of light.
the latency equation, yes.
Yeah.
This is the first objection every CTO brings up. Data moves fast, but it isn't instant.
Right. Fiber has resistance, routers add delay. A server in Dhaka is just physically farther from a user in Delhi.
So for things like high-frequency trading or, competitive online gaming where every millisecond counts,
Nepal is a non-starter.
it is.
Yeah.
The physics don't work. But, and this is the key insight people miss, not all AI workloads are the same. Not everything needs to be real-time.
The report makes a distinction. It's not just training versus inference.
Right. The sweet spot for a place like Nepal is what we call asynchronous compute.
Batch processing.
Exactly. Think of tasks that are massive, power-hungry, but you don't need the answer this second.
Like a drug company screening millions of molecules to find a new cancer treatment.
Perfect example. They upload the job, they hit go, and the AI just churns on it for, say, 12 hours.
And does it really matter if the answer comes back in 12 hours or 12 hours and 3 seconds?
It doesn't matter at all. What matters is what it costs you to run that 12-hour job.
I see. Or an animation studio rendering frames for a movie. They send it to the render farm overnight.
Exactly. Or banks running overnight risk analysis on their loan portfolios.
Yeah.
These are all back-end workloads. They're the heavy lifting. They're indifferent to a few milliseconds of lag.
So that's the strategic pivot. Nepal shouldn't try to compete with Mumbai to serve someone scrolling an app.
No.
It should aim to be the engine room in the back.
The report says Nepal shouldn't try to be the showroom. It should be the factory. You keep the user-facing stuff close to the user, but you offload the heavy, expensive grinding to the mountains where the power is cheap.
Okay, so power is number one. But there's another huge cost that people forget about, and that's just keeping all this gear from overheating.
Cooling.
Mm.
It's the silent killer of data center profits.
Hmm.
You're basically fighting a war against thermodynamics, pumping tons of electricity into massive air conditioning systems.
And that's measured by PUE, right? Power usage effectiveness.
It is. A PUE of 1.0 is the ideal. It means every single watt goes to computing. A PUE of 2.0 means for every watt of compute, you're using another watt just for cooling.
So if you're building in a hot, humid place like Chennai,
You're fighting the environment. You struggle to get a PUE below 1.6. Your AC is just blasting 24/7.
and this is where Nepal's geography becomes a huge asset, the Dolaka blueprint.
Dolaka is a district in the mountains. The average annual temperature is about 16 degrees Celsius. It's naturally cool,
So you can use ambient air cooling.
which is really just a fancy way of saying you use the cold mountain air to cool your servers.
But it sounds so low-tech.
It does, but it's incredibly effective. You filter the air, of course, but you're not running power-hungry compressors. A data center there could achieve a PUE of 1.2.
So what does that actually save? Going from 1.6 to 1.2?
On a 100-megawatt facility, that efficiency gain saves you about 350,000 megawatt hours a year.
Which is...
Tens of millions of dollars
Yeah.
annually, just from the weather.
That's wild. So you get a double discount. Cheap hydropower and free air conditioning.
That's the unique combination. And the report suggests taking it a step further, vertical integration, building special economic zones right next to the hydro plants.
So the server farm is literally inside the power plant's fence.
Pretty much. You plug directly into the high-voltage substation.
No transmission loss.
You minimize loss, you guarantee power quality, and you turn that power plant from just a generator into a digital hub. You stop selling raw electrons and start selling high-value data processing.
It all sounds almost too perfect, which means we have to talk about the hurdles. Because if this were easy, someone would have done it already.
Right. And the report lays out two futures. The first is the status quo, the battery pack scenario. Nepal just keeps exporting raw power to India.
They become the Duracell for South Asia.
Exactly. India buys the cheap power, runs their own data centers, and captures all the digital revenue. Nepal gets a check, but they miss out on the whole AI revolution.
And the second path is the green compute gambit. But the report is pretty tough on the current policy environment.
Tough is putting it mildly. The big issue for foreign investors is regulatory instability. To make this work, Nepal needs a new Digital Infrastructure Act.
And what would that do?
It would provide certainty.
Yeah.
First, long-term PPAs. You can't build a $1 billion facility if you think the government might triple your power rate next year.
Makes sense.
And second, currency risk. Investors are putting in U.S. dollars. They need contracts priced in U.S. dollars, so they're not exposed to fluctuations in the Nepali rupee.
Okay, but even if you fix the policy, there's still one huge Achilles heel that the report identifies.
Connectivity.
The deficit of photons.
You have a surplus of electrons, but a deficit of photons. You can have all the power in the world, but if you can't get the data in and out reliably, you're dead in the water.
And right now, Nepal is landlocked and relies on fiber routes coming up through India.
Which is a massive single point of failure. Imagine a backhoe in Bihar accidentally cuts the main cable. Your entire data center goes dark.
That's a complete non-starter for any serious enterprise.
Absolutely. Capital will not flow until the data can flow with 99.999% reliability. The report is clear. Nepal needs redundancy. They need separate, privately operated fiber routes through both India and China.
The north-south redundancy.
You need two distinct paths to the global submarine cables. If the southern route to Mumbai goes down, traffic automatically fails over to the northern route to Hong Kong.
That's a massive infrastructure project, laying what the report calls the glass arteries of the country.
It is. Building across the Himalayas is incredibly difficult, but without that optical redundancy, no major tech firm is going to take the risk.
So the barrier isn't really technological, it's institutional, it's infrastructural.
That is the absolute crux of it. The tech is there, the cooling is free, the power is literally spilling over the dams, the market demand is insane, the only missing pieces are the legal framework and the fiber optic cables.
And the clock is ticking on this.
It really is. These huge AI infrastructure decisions are being made in boardrooms right now. If Nepal waits 5 years, the industry will have already found other solutions. The window won't be open forever.
So, to summarize the argument here, Nepal has this incredible opportunity, a green battery strategy. It combines cheap green power and natural cooling to cut the total cost of ownership by a quarter.
As long as they target the right kind of work, that asynchronous compute, and, crucially, solve that connectivity problem.
It's a fascinating strategic challenge. It kind of flips our whole idea of development on its head.
How so?
We think of industrialization as factories and smokestacks. Here, industrialization is servers and clean water and fiber optics.
It flips the script on geography, too. For centuries, being landlocked in the Himalayas was an economic curse. It made trade hard.
An obstacle.
But in the digital age, the mountains provide the cooling. The rivers provide the power. Suddenly, that geography becomes a competitive advantage.
A fortress of efficiency.
Exactly. But I'll leave you with this thought. The biggest barrier isn't the mountains anymore. It's the mindset. The first critical investment for Nepal isn't in servers. It's in those glass arteries.
So the question for them is,
Will they choose to just be a simple battery, exporting their raw potential? Or will they build the connections required to become a prime mover in the 21st century economy?
that is the multi-billion-dollar question, a surplus of power, a surplus of potential, just waiting for the connection.
Indeed.
Thank you for listening to this deep dive analysis from Alpha Business Media. We'll catch you on the next one.